Hello and welcome to Varsity Eco. Today we are going to work with budget line, and you may think what is there to discuss because it's just a line. But we are going to take some cases which makes things a little bit difficult. For example, we are going to consider the role of taxation, how it may rotate the budget line, and not always the whole budget line, but also some part of the budget line which will ultimately end at a kinked point budget line. We are going to discuss rationing a little bit, and then we are going to discuss the famous one, which is gift in cash and gift in kind. And only after that we will move on to the utility maximization problem, UMP in short. Okay, so let's start. So budget line also, like every other structure in economics, comes with some assumptions and obviously one definition. Okay, so the assumptions first. Assumption 1. These assumptions will ultimately help us in a very different time point in microeconomics when we will be discussing perfect competition. So the first assumption is price of every good is positive. In the standard budget line, nothing is free. Assumption 2. Price taking behavior. Nobody can influence these prices. Okay. Assumption 3. Consumers' income is finite, because otherwise we will not have a solution of our problem. Okay, so now the definition. So budget line is the locus of all possible combinations of commodities for which given prices consumers' expenditure equals income. Now this is, at this time point, this is very trivial, but this consumer's expenditure equals income, this is actually a requirement that we need to fulfill to have a solution, because if the consumer can save, which we generally do, then we cannot possibly find a unique solution of the maximization problem. Okay. So in our two commodity world, the world that with which we started, in our two commodity world, we noted commodities are good 1, good 2. So x1, x2. Then their prices P1, P2. Then the income M. So our budget line is P1x1 plus P2x2 equal to M. Now obviously, if the consumer so chooses, at least theoretically, it is always possible that you actually save some amount. Right? So that is why, in general, we use a term which is called budget set, which is basically the same thing with a less than equal to sign, and this is called Walrasian budget set. So Walrasian budget set, the end point is basically the line, the budget line. We in UG, we always talk about the budget line because the optimal will be always on this budget line. So let us draw first the simplest diagram, then we are going to change things a little bit to make it slightly difficult and to allow other problems. Okay. So good 1, good 2, or we can at this point also write x1 and x2, no harm. Our straight line, this is our budget line, p1 x1 plus p2 x2 equal to m. And if we go about the less than region, then this is the region, and in totality, including the line, this is called the Walrasian budget set. So some of the things that we can readily derive from it. Number 1, if differentiated, that's a very simple task, right? I'm not going to do it in detail. So dx to dx1 will be minus p1 by p2. So that's our slope. Okay. And intercepts. So on the x-axis, we have the highest amount of x1 here that can be bought. So let us write x1 max, which is equal to m by p1, and then on the y-axis we have x2 max, which is m by p2. What happens when prices and income change? To answer that, we can either go by slope, or we can also go by these intercept values, whichever you find easier to deal with. Okay. All right. So we have only two options here actually, only prices and income. So either they can change separately, that is separately change of prices, change of income, or obviously separate change of price of one single good, or they change together. So let us look at those easy things. First, the easiest one, effect of change in income. So the effect is pretty simple. Shift of the budget line, and if M increases, then it implies outward. If M decreases, then it implies inward. Okay. So diagrammatically speaking, if this is the old one with, let's say, some income M naught, then this is the new one with some income M1, which is obviously greater than M naught. We can also think that if the income increases, then our buying capability here in these two increases by the same ratio. So then again, we got a shift. Okay. Now, effect of change in price of only one, in price of, let's say, good one. So if P1 decreases, then M by P1 rises, which implies intercept rises, which implies a rotation, and in which direction? Like this, so rightward. Okay. So if this is my old budget line with a price of P1 naught, and if this price decreases, then it will simply be something like this with P1 1, which is obviously less than P1 naught. And analogous things hold for the second good. Also by slope, we can write that if P1 reduces, budget line becomes flatter. So this is a more common way of saying it. That's how in everyday classes we refer to it. Okay. So the opposite will be true if the price of good 2 changes. Okay. And it will be visible in x2's axis. Okay. Now, there can be one scenario where the changes will happen in the prices, but it will look like income has changed. So how does that work? Effect of change in prices of both goods by the same ratio. So what if P1 becomes alpha P1 and P2 also becomes alpha P2? So if we put those values here in the slope, we'll see that slope remains same. But then if we put these values in these places, then we see that the intercepts, they reduce by the same amount. So price has changed, but it looks like the income has changed. So if we have to draw a simple diagram, it will be exactly same with reduction in income. So x1, x2, and this is our old budget line with price pair P1, P2. And say this is our new budget line with price pair alpha P1, alpha P2. Obviously alpha is positive. Okay. Now we are going to move to some of the more difficult cases, because discussion on budget line, if it has to be meaningful, then is incomplete without the cases where budget line has kinks. So we are going to talk about 3 scenarios of kink budget line. Okay. So kinked budget line. In that we are going to deal with first rationing. Okay. So some amount of one good will be given either for free or for a lower price, or we can consider that beyond some amount one of the commodities is simply not available. Number 2 is taxation with rationing, in the sense that beyond the amount of rationing the price rises. And number 3, this is the classic in micro, that is gift in cash versus gift in kind. It has some optimization issues involved with it, but understanding the budget line is the first part of it. The next part is obviously understanding the optimization. Although we have not covered optimization, but just after this we are going to deal with it. So we are going to take a brief look at this optimization issue with diagrams. Okay. So let us go to the next section. Okay. So let us start with rationing. Now we have 2 ideas of rationing. Okay. So in India, I think the more popular way of dealing with this idea of rationing is that the first few units of that commodity is available at a lower rate, and beyond some amount it is not available at the ration shops, but you can buy it at the market price. Now that's slightly more complex scenario. Before going into that, we are going to talk about rationing in a more simpler fashion, and that simple case is this. let us say that is case 1. So case 1 is good 2 is being rationed in a way that it is not available beyond x2 equal to x2 bar. Okay, so it is few in numbers, so whenever you go, you cannot get more than that, right? So what happens to budget line in that case? Pretty simple, x1, x2, and let's say this here is our x2 bar. So what happens is this: you have price setups P1, P2. Obviously with this budget line P1 x1 plus P2 x2 equal to M. Now, since there is no issue with good 1, you can buy good 1 up to M by P1. So let's say it is that point. Alright. And obviously till x2 it will follow the price ratio of minus P1 by P2. Right? So it will go like this. Let's say it will follow this slope. Okay, so we'll come to that. But the point is that if it is being rationed, that means that originally you can actually buy more than x2 bar. So this is the basic idea, that without rationing you can go beyond x2 bar, and which diagrammatically, which essentially means that if I want to find the maximum amount M by P2, then this will be higher than x2 bar. So that is the whole point of rationing here, right? So that means that if you are only up to x2 bar, then the x1 amount that you can buy parallel to it is not 0. What is that amount? So that amount will be, let's say that is P1 x1 some star, so you can go up to only x2 bar. So then your x2 bar will be equal to, so here I can find the value, so M minus P1 x1 star divided by P2. So that is our x2 bar here, which is obviously less than M bar by P2. But that means that the corresponding x1 star is non-zero. So let's say this is our x1 star. Okay, so let us look at this point. So this is the point. So till x1 star, your budget line is a flat line, and beyond x1 star, okay, so again with your money you can buy max amount of x1, there is no issue. And since you are not allowed to go beyond x2 bar, till x2 bar it is fine, you are going to the budget line, but once you reach x2 bar, no going further. But the point is that this is an effective rationing, so that means corresponding to x2 bar, your x1 is not 0, it is some value of x1 star. Because see, if I put x1 star 0 here, then again it will be M by P2, so your rationing becomes ineffective. So to make it effective, I must have x1 star non-zero. Okay, so the diagram will look like this. Now the Indian scenario that we are talking about, that you have a limited amount at a lower price, and if you want beyond that, you have to pay higher prices, the market price. That's a slightly difficult case. But let's, for the time being, extend this one. What happens if this is the scenario that beyond x2 bar, consumers need to pay higher prices, okay, like that happens in India, possibly due to taxation. So what happens then? Then this is the scenario that till x2 bar P2 is the price and slope is minus P1 by P2. And for any x2 greater than x2 bar, P2 plus some tax T, okay, so let's say this is our GST, is the price and slope is minus P1 by P2 plus T. Okay. Although we consider a unit tax, GST is a percentage tax, but all those distinctions are fine. Then we will deal with that in demand supply taxation scenario. Here we are more interested in this fact that beyond this amount, you have to pay a higher price, the market price, let's say. So if the slope is now higher, that means that beyond this point you cannot really reach M by P2. So if the prices are higher, then that means your maximum amount is reduced now. So your budget line will be steeper. So something like this. Okay. So just to compare and give you the picture, had there been no tax, your usual budget line would have gone in this direction. But that is not happening. Rationing till x2 bar. So if you want more than x2 bar, you have to pay a higher price due to taxation, and that reduces the slope from this region. Okay, so your end point is not M by P2, it is higher. Alright. And if there were no scenarios like this, you would have reached this higher point. Okay, so let us name this scenario as case 2 to adjust with our picture. Alright, and I mean, you may feel that we get so small amount under rationing, so this x2 bar must have been a little bit lower, but it's fine. The diagram will look like it, and we have our kink here. Okay, so in the next scenario, that is gift in cash, gift in kind, I said that there is a role of optimization also. This classic example shows us that the effect of this kink, okay, what happens in the optimum bundle of a consumer. That is what the central focus of gift in cash and gift in kind. And I know that many of you believe that gift in cash is better than gift in kind. That's not really true. There can be scenario when they are equivalent, and in some other scenario, obviously gift in cash is better. Actually, saying the opposite thing is true, that gift in kind cannot generate more utility at optimum than gift in cash. That is not possible. So okay, so we are going to see it now. Okay, so with gift in cash and gift in kind, the idea is very simple. Say it's your birthday and people come with the birthday cake, and instead of coming with that cake, people actually come with the money, which is equal to the price of that cake. Alright, and we are going to see what happens to utility in these two cases. Okay, so first we must start with the budget line. Alright. So again, x1, x2, and the standard equation is same, p1 x1 plus p2 x2 equal to m. And let's say this is our, okay, we're going to put both of them in the same diagram anyways. So kind, let's say this x1 is your k, and people arrive with that. So that means first free amount of x1, let's say x1 bar, is already available to you. Okay, and the maximum amount of x2 that you can buy is m by p2. So if this is your point of m by p2, then you don't start from here, but actually you start from this point. Alright? Because now you have the first sum of the units free. So instead of gift in kind, you can think of a free good also. Free for some of the first few units. Beyond that, obviously, is the same scenario with a slope of minus p1 by p2. Alright, so I'm going to just draw that. Okay. So this is the case when you have kind. Now, we have assumed a structure or assumed a scenario. What is our assumption? And this assumption is very important. It is that the gift in cash will be of the same amount that is required to buy the gift in kind. Okay, because if somebody gives you more money, then it's all the more better, but then it will not be really comparable. Alright, so if somebody gives you the money instead of this, then obviously you don't have this free part. Now you start from zero. But there's a big change. The big change is that now you can go higher because the slope will remain intact. So where will you go? Because you have higher money, so your x2 max will increase. So now with higher m, x2 max will rise. So that is the gain part, but x1 minimum now is equal to 0. Right? Now you have to start from 0. So that is the crux of this scenario. So then it will go with the same slope much higher up. So like this. Okay. So this is your cash. Now this is the change in the budget line. Alright. So if you have kind, you have first some units free. If you don't have it, obviously you have increased money, so your x2 max will now go higher. But now you don't have the first few units. Now, one common question that we face in these situations of festivals or birthdays, typically, the people come up and ask us directly, what do you want as your gift? Alright? Why? So that the scenario that we are going to discuss now is the scenario that occurs. What is it? If your IC indifference curve is positioned like this, right? Let's say like this. Let's say this is E1, then your optimum point is E. Okay, so your IC, your desire, and your ability that matches at this point E. And it doesn't matter whether you have the kind or the cash, because this extended portion has no effect here on this equilibrium, on this tangent point. But what if this is not true? What if your IC's, that is your map, looks something like this, and that's a different map. Okay, so this is one kind of map, and let's say your map looks like this, right? So then what happens? Then you are at the kink. with the kind scenario, you are at the king, so this is your E kind. And you are at that point forcefully because people come up with that cake. So if I bring something that is a gift in kind but you simply hate it, then you are in this kink. And you would have liked the cash because if you had the cash, then you would have optimized somewhere here. Right? So let's say EC. No, here, but let us write here. So EC. Okay. Let us write EK here. So you can readily see that in case 1, when your equilibrium is E, this remains unaffected by cash or kind. So cash is equivalent to kind. But in case 2, where equilibrium is at kink, then EK provides you the utility of U1, which is typically less than U2, which you can obtain if somebody has given you cash. Right? So this is the problem, the classic example of gift in cash and gift in kind. So the first part obviously is the budget line, the king here, that creates all the differences. And the second point is your indifference map. Right? This indifference map is very different from this indifference map. So that is why when you are going to attend someone's birthday, it is better that you ask what you want in your birthday, so that the birthday person, the individual on birthday, remains at E and not face a dilemma between this EC and EK.